Now, calculating mean is something that you've probably done before, but what you might not have seen is that there's a few different notations for the mean. X bar is what we call this one, mu, or the expected value of x. And in fact, we use both of these notations already in our unit on probability. Now, you probably already know how to find the mean of a bunch of numbers. You literally add all of the numbers up and then divide by how many there are. And this formula means exactly that. Take the sum of x, where x is all the scores, and divide by n, where n is the number of scores. So here I have a list of numbers. Let's say I've asked a bunch of people, 15 of them, how many siblings they have. And these are their answers, lined up in order. I've simply added them all together and got 27 and then divided by 15. And this gives me a number that's, a little less than 2. But remember, we can arrange that exact same data into a frequency table. And when we do that, the same data looks different. We've got the number of people who had 0, 1, 2, 3 or 4 siblings written here as a frequency. Remember, there were 2 people with no siblings, 4 with 1, and so on. Now, it made sense that when we worked out the average a moment ago, we added up the total number of siblings. Well, if 2 people have no siblings, how many siblings altogether do those 2 people have? We need to multiply these together to say they don't have any siblings. If 4 people have 1 sibling, clearly that's 4 siblings total for those people. 5 people have 2, that's another 10 siblings. And you can see here that we can get our 27 siblings by adding up this column, where this column is made up of these columns multiplied together. Now, when we add up the frequency, we should check that we've got the correct number of people altogether. And then it's just a matter of dividing our 27 by 15 this way. So we're doing the exact same thing, but if our data is presented to us like this, we would probably use a different version of the formula. We would say, let's multiply each score by how often it happened, add all of those together, and then divide by how many scores there were. So this makes sense to add up all the siblings first. I mean, that's what we did when we did it the first method, and then divide by the total. Now, this is really similar to the concept of the expected value in probability distributions. And remember, the expected value is just another way of saying the average or the mean outcome. And in probability distributions, we learnt to weight each score according to the probability of it happening. And the way that we did that, we took the sum of each score multiplied by its probability. Now, how do you work out the probability of something? Well, it's a fraction, isn't it, of how many times it happened out of how many times there were in total. So what we're doing here with our frequency divided by the total number of scores is actually effectively the same thing. You can see here that if we take the sum of x times by the probability, that's the same as taking the sum of x multiplied by the frequency of it happening over how many total things happened. And in fact, if we want to multiply something by a fraction, and then take the sum of it, then we can actually just take the sum of x times f and divide by n afterwards, and we'll get the exact same thing. Now, in this frequency table, we have actual discrete scores, discrete data. But if we had continuous data, we could do the exact same thing here and use the same formula. And the difference is we would use the class center as our score each time, which would lose a little bit of the detail, but it would still allow us to make our calculation nice and easily.